All right, this is an example of balancing a chemical equation. Here we have a chemical, hydrogen peroxide, you're familiar with. Here we have a chemical, water. Oxygen is also present, right there. And the formula for hydrogen peroxide is H2O2. We can't change that because that's the chemical formula. You can't change the subscripts. This is oxygen in air. Of course, it's a gas at room temperature, bouncing around really fast. Okay, it contains 2 oxygen. That's why there's a subscript of 2 in 1 molecule. Here's water molecule, one of the most famous chemical formulas in the world, except for the way organic chemists write it. They write it HOH, but it's the same thing as H2O. 2 hydrogen, 1 oxygen. Okay, the problem is this is not balanced. We are breaking the law. We have to obey the law, the conservation of mass, and make sure that everything that goes in also comes out. This is the middle, the yield sign. Everything on the 2 sides needs to balance. Just like on a balance, okay? Just like on a balance, the 2 sides need to add up to the same mass. The only way they can be the same mass is if we have the same number of the same atoms of every element on each side. So let's see, 2 hydrogen, check, that's good, that's balanced. 2 oxygen, 1, 2, 3 oxygen. And you can see that here, okay, because all of the coefficients are 1, they're invisible ones. You could imagine ones in all these places. 1 times 2 is 2. 1 times 1 is 1. The total on this side is 3. This side is 2. 3 to 2. That's one of the techniques in balancing. If you ever run into a situation where there's odd on one side, even on another, make the odd side even to fix that. So the number one way that we fix that is find which part over here is making it odd. Well, this is 2, that's an even number. But this is the odd one out. So in order to make this work, we know we're going to have to make the odd side even. We're going to have to double, put a coefficient of 2 in front of the odd part. That gives us 2 water molecules. That's what that 2 means. It multiplies by the whole thing. It means we have 2 water molecules. But now notice that has messed up the balance of hydrogen because now we have 4 hydrogen on this side. 1, 2, 3, 4. 2 times 2, 4 hydrogen. But we only have 2 on this side. Well, the only way to get more hydrogen on this side is to have more hydrogen peroxide. So then I could put a coefficient of 2 here. That coefficient means that I get another hydrogen peroxide on this side. They're not merged into one. They're 2 separate molecules, but it means I need 2 of them for this to work. Okay, so let me slide these downward to be sort of in the middle here. And then let's put the oxygen right there. So now let's see. You can visually see that 1, 2 oxygen here, 2 oxygen there. 2 oxygen here, 2 oxygen there. There's 4 total on this side, 4 total on that side. There's 4 total hydrogen atoms on this side, 4 total hydrogen on that side. By the way, this reaction, even though it is going here, it is going in here, all just like this, inside. Okay, and now by the way, this is balanced. So I like to put a little check if I think it's balanced. Okay, it's going on in here, but we can speed it up with the catalyst. The catalyst I use in my demo is called manganese dioxide. This little powder that I put in speeds the reaction up a lot. So one way to show a catalyst is to put it above the yield sign, like right there, or to write above the yield sign what the catalyst is, like MnO, okay? MnO2, excuse me, manganese dioxide, not magnesium, manganese. Or another thing I could do is I could put it on both sides. Let's see, I could put it over here. I don't know, I don't have room for it, but let's say I have a plus MnO2 over here, and I put it on this side, plus MnO2 on this side. But of course, that's not going to affect balancing. I don't have room to put it. It would actually be written separately. But if you see the same exact chemical on both sides, you can always ignore it when it comes to balancing, also when it comes to reaction type. So what kind of reaction is this? Do you think this is combustion because it has oxygen? it is actually very, very far from combustion because actually oxygen is on the wrong side. For combustion, you need oxygen on the other side, on the reactant side. This side is called the product side. So when you have oxygen on the product side, it is definitely not combustion. Okay? So what kind of reaction is this? One reactant. Even though there's two molecules of it, it's one reactant making two products. What kind of reaction does that sound like? Which of the 5 reaction types? We said it's not combustion. It is, which of the other 4? It is decomposition, because it's one chemical breaking into 2 others. Okay, so that is an example of a fairly easy reaction to balance. And I'll show you a harder example next.